Now let's talk about when resistors are placed in a parallel form or in the form of a parallel circuit. Now, one thing you need to know about parallel circuits is that the current has different pathways on which they move. Now, in a series circuit, the current only moves along one path. Now, the voltage is the same across all resistors. So V is always the same. R, for the R's, we have R1 and then we have R2. Now, we also know that if you want to add the current, the total current in the resistor, you're going to add the current in this section and then the current in this section, and that will give you the total amount of current that is being carried. So I is equal to I1 plus I2. Now let's change the formula of I into this form. When you take the formula triangle, you get R on this section, V at the top, and I on the other end. So if you want to make I the subject, I is equal to V over R. So now we are changing all I's to V over R. Now V over R, which is the total resistance, is equal to V over R1. R1 has to do with the resistance in the first resistor, plus V over R2, which is the resistance in the second resistor. Now the V's do not carry numbers because voltage is the same everywhere. Now what is going to happen is that we are going to divide all sides by V. So V over R times V is equal to V over R1 times V plus V over R2 times V. Now the V's cancel out. This V will take this V away. This will take this away. This will take this away. Now what we are going to be left with is 1 over R is equal to 1 over R1 plus 1 over R2. Now this is the formula for finding the resistance in resistors that are arranged parallel to one another.